The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, today we start chapter 9. We're going to take a look at section 9.1, which has to do with radical expressions and radical functions, or roots would be another name for them. So let's take a look here. If I were to say, tell me about your roots, am I asking about your hair roots? What would I be asking about if I said, tell me about your roots? Any idea? Anybody?
Family heritage.
Family heritage, where you came from. Sure. Okay. So let's say we have the number 0 and we square it, we get 0. Well, that was pretty exciting, wasn't it? If we take 1 and we square it, we get 1. But if we take 2 and square it, we get 4. 3 and square it, we get 9. 4 and square it, we get 16. 5 and square it, we get 25. 6 and square it, we get 36, etc. All right. These are called perfect squares. They have two identical factors. We took some number and we squared it and we got these perfect squares. All right. Now, let's take the number 16. 16 is a perfect square. Where did it come from? It came from 4 squared. So if we take the number 16 and we say, where did its square come from? We're saying, where is its square root? What's the root of this square? What number did we take and square to get 16? And that would be 4, because 4 squared is 16. The square root of 16 is 4. Or we could even say this, the square root of 4 squared is 4. The square root undoes the square. Any questions about that example? All right, now, if we take the square root of 1, we get 1. The square root of 4, we get 2. The square root of 9, we get 3. The square root of 16, we get 4. But what about the square root of 2, or the square root of 3, or the square root of 5, or the square root of 10 for that matter? Well, if you take the square root of a perfect square, you get a nice answer. If you take the square root of a number that is not a perfect square, you get something that is called irrational. And as a decimal number, it just kind of goes on and on and on and doesn't terminate. Okay. Now, if you take the square root of a perfect square, you get a nice number. The square root of a positive not number, you get something that's irrational. If you take the square root of a negative number, you get something that is not real, or it's imaginary. But we're going to just stick with not real for right now. So you can't take the square root of a negative number and get a real answer. Okay. Now, 4 squared equals 16. But negative 4, the quantity squared, also equals 16. But when we take the square root of 16, we just get the positive root, which is called the principal square root. So 2 things. You can't take the square root of a negative number and get a real answer. When you take the square root of a number, you can't get a negative answer. So when you're doing a square root, you can't have a negative inside and you can't have a negative outside. Okay. This not only is good on square roots, but 4th roots and 6th roots, any even root. And we'll talk more about that right now. Let's take a look at the notation and the names for things. So let's say I've got the square root of 4. This is called a radical symbol or a radical sign. This number inside is called the radicand. So the radicand is the quantity inside of the radical. Okay. So the radicand can't be negative. The radicand has to be greater than or equal to 0, or we get something that is not real. Now, right here, there isn't anything written, but when there's nothing there, it's an implied 2 to say take the second root. Let's take a look at this example. This says take the cube root of 8. The 3 is called the index. It tells us what root we are taking. We'll come back to that in a minute. All right, so the square root of 4 is 2 because 2 times 2 is 4. The cube root of 8 is 2 because 2 cubed is 8. Now I said that you couldn't take an even root of a negative number. However, you can take an odd root of a negative number. That would be -2 because -2 times -2 times -2, or -2, the quantity cubed, is -8. All right, so again, you can't take an even root of a negative number, but you can take an odd root of a negative number. When you take an even root, you can't get a negative answer. But when you take an odd root, you can get a negative answer. So the restrictions lie within the even roots. Okay. Any questions so far? Okay, let's take a look at some examples of some problems. It says evaluate each square root without using a calculator. So the square root of 49 is some number such that that number squared is 49. Well, what positive number squared is 49? Anybody?
7.
Right. So the square root of 49 is 7 because 7 squared equals 49. Okay. Now, what about the square root of 64? What would that be?
8.
Okay. What about negative the square root of 64? The negative sign is outside of the radical. Among other things, the radical is a grouping symbol. It separates what's inside from what's outside. So order of operations, the square root of 64 is 8, but then the negative sign outside gets applied. So negative the square root of 64 would be -8. Any questions about that? All right, let's say we have the square root of 4/25. Well, what's the square root of 4?
16.
Square root.
2.
Oh, 2.
Right, going the other direction. What's the square root of 25?
5.
5, right. So the square root of 4/25 is 2/5. Questions about that? All right. What about the square root of 0.16? Well, what's the square root of 16? Just 16.
4.
Right, okay. But this is 0.16. So would it be 0.04?
Yes.
Well, let's see, what's 0.04 times 0.04? That's 16, but then we'd add, no,
True. So then 0.4?
there you go. It's kind of tricky because 0.4 times 0.4 is 0.16. Okay, great. Let's see here. What about the square root of -81? Let's write that a little better. Square root of -81. What would that be?
-9.
9.
Not real. You
Oh, it's negative.
you can't take a negative root, or can't take an even root of a negative number. Right. Okay. Calculator time. On your calculator, now, I don't know which calculator you have, but if you have the one that's recommended for this class, which is the TI-30X Roman numeral 2, there is a button over on the left column. There's a little button that has a little caret thing on it like that. And right below that, there's a button that says x squared. And the second function of x squared is a square root button. Be careful, because the second function of the little caret is the xth root, and we'll talk about that later. But so we want the square root button. So to get the square root of 12, I'm going to go, oops, second, and then the x squared, which will then access this. Okay, so second, and then this is what shows up. Then I type in 12 and close up the parentheses and push equals, and I get 3.4641011615. But the directions said give each answer to 4 decimal places. So that would be right here. The 0 would round down. So the answer would be approximately 3.4641. If you have a calculator there, I would advise you to try that right now. If you don't, then you can try it later to make sure that things are working fine. Any questions about that problem? Okay,
No.
let's do one more. The square root of 0.0063. Second. Boy, it's having a fight there, Antonia. All that noise.
It's the table.
All right. So second square root of 0.0063. Close it up equals. I'm getting 0.079372539. 4 places. The 7 rounds up. So you'd get that. Any questions about that problem?
Yes, I do have a question. How you said I could get it in the calculator? I pressed the second button?
Okay, do you have the calculator like I have?
Yes.
All right, so with the calculator on and the screen cleared, you push that blue second button,
Yeah.
then push the button that says x squared, and this should appear on the screen, the square root with parentheses.
Yes. Yes.
Then type in your number there, then push a right-hand parentheses and push equals.
Oh, got it. Okay, thank you.
Is that working then?
Yes.
Okay, any other questions about that at this point? All right, let's take a look at the following. It says, simplify each expression. Assume that all variables are unrestricted. So what that means is the variable, in this case, x, could be a positive number, it could be a negative number, or it could be 0. They aren't telling us. We have to assume it could be anything. It says, and use absolute value symbols when necessary. Okay. What is the square root of 4?
2.
2. What is the square root of x squared?
X.
But here's the problem. In fact, let's come back to this. Let's go to one that's just a little bit simpler. Now, if we say the answer to the square root of x squared is x, there's a problem because they said that x is unrestricted. So x could be any real number. What if x is negative? Well, then you've just gotten a negative answer. Remember, you can't take an even root of a negative number, and you can't get a negative answer when you take an even root of a positive number or of 0. So what we have to do here is put absolute value bars around X, the answer. That way, regardless of what X is, it's not going to be a negative number because we're taking its absolute value. Okay. That's going to be a little hard to swallow, but you'll get there. So up here, this is the answer, 2 times the absolute value of X. Since I don't know if X is positive or negative or 0, I have to assure whoever that it isn't a negative number because I can't get 2 times a negative number, which would be a negative number. You can't get a negative answer when you're taking an even root. Okay, let's take a look at this. So let's put this back up here. The square root of 4x squared is 2x with the absolute value bars on X. What about the square root of 81h to the 4th power? What's the square root of 81?
9.
Okay. What's the square root of h to the 4th? So h to the 4th equals what times itself?
Be h squared.
Right.
Absolute value of h squared.
Actually, no.
No?
Why don't I need absolute value bars around h squared? Consider this. If h is positive, what's a positive number squared?
Positive?
If h is 0, what's 0 squared?
0.
If h is negative, what's a negative squared?
Positive?
So because the variable is squared, it doesn't matter whether h is positive, negative, or 0. H squared won't be negative, therefore we don't need absolute value bars. Are you seeing that?
Yes.
Is your head starting to hurt? Not yet? Okay, well then let's keep going. How about this? The square root of 36 s to the 6th power. Okay. What's the square root of 36?
6.
6.
What's the square root of s to the 6th power?
S cubed?
All right. Do I need absolute value bars here if s is unrestricted?
Yes.
Yes, I do, because s cubed, if
Is a
s is negative, cubing it, it would still be negative, wouldn't it?
Yes.
Yes.
All right. How about this one? 144 m to the 8th power square root.
It's 12.
Okay, 12 m to what power?
The 4th?
Right. Do I need absolute value bars?
No.
No,
Right, because m to the 4th power wouldn't be negative.
but it's only even. It's even.
Yeah.
Got it.
Okay, excellent. What about this one? Now, you need to understand something about radicals. This is not equal to the square root of b squared minus the square root of 14b plus the square root of 49. This would be b and this would be 7 and this would be something else. Doesn't work that way. But what we can do is factor this into a perfect square trinomial with 2 identical factors. Then the square root would be b minus 7, except the restrictions still apply. This was still under that same set of problems. So b, the variable, could be any real number. So we can't make this a negative answer, so we need absolute value bars around it. Okay? Any questions there?
Nope.
All right. Let's go back up here. And And let's see here. All right, we've got f of x equals the square root of x. Okay. Now, notice that all the x values are perfect squares. So if x is 1, f of 1 would be the square root of 1, which is, oops, 1. Sorry, I skipped over 1. Hang on. If x is 0, f of 0 would be the square root of 0, which is 0, right? Antonia, could you turn your mic off? There's a bunch of noise coming through. Thank you. All right. If x is 1, f of 1 would be the square root of 1, which is 1. If x is 4, f of 4 would be the square root of 4, which is 2. If x is 9, f of 9 would be the square root of 9, which is 3. And if x is 16, f of 16 would be the square root of 16, which is 4. So the table, the x values are perfect squares. Therefore, when you take the square root following the function, you get nice numbers. Then it says to go ahead and, let's see, graph it. So we've got 0, 0, 1, 1, 4, 2, 9, 3. Well, let's see here. 9, 3, this is 6, 7, 8, 9. So we're going to be up like there somewhere. So the graph starts at the origin and goes up and to the right. Any questions so far?
No.
What's the domain of this graph, which is a function? What's the domain? Where does it start?
0.
Okay. Where does it end?
16.
Where does it end?
Oh no, infinity.
Right, it doesn't end.
Yes.
Okay. Yeah, this is not all the graph. That's just getting it started. What's the range?
Zero.
To what?
Infinity.
Excellent. Okay. All right. How about, let's see here. This one. It says, graph each function, give the domain and range, see examples. Oh, well, yeah, okay. So graph each function. F of x equals the square root of x plus 4. So the plus 4 is inside the radical. So if we use 0, 1, 4, 9, 16, that's not going to give us perfect y values, because when we put those x's in there, we're going to add 4 to that x value. So what we need these x values to be 4 less than those, so that when we put them in here and we add 4, we get back to perfect squares. I don't know if that's making any sense or not. What's 0 minus 4?
-4.
What's 1 minus 4?
-3.
What's 4 minus 4?
0.
What's 9 minus 4?
5.
What's 16 minus 4?
12.
Now, if I use these numbers, let's see what happens. If x is -4, f of -4 equals the square root of -4 plus 4, which is the square root of 0, which is 0. Nice number. If x is -3, f of -3 equals the square root of -3 plus 4, which is the square root of 1, which is 1. Nice number. If x is 0, f of 0 equals the square root of 0 plus 4, which is the square root of 4, which is 2. If x is 5, f of 5 equals the square root of 5 plus 4, which is the square root of 9, which is 3, etc. So do you see, by making my x values 4 less than the perfect squares, then when I go in here and add 4, it turns them into perfect squares. Order of operations, you do what's inside the grouping symbol first. So you take whatever the x value is plus 4, and then you square root that. So what do I get? I get -4, 0, -3, 1, 0, 2, 5, 3. Well, that looks just like that graph, doesn't it? Except it's been shifted to the left. In fact, how far has it been shifted to the left? Can you see? It's shifted 4 units. So adding a +4 in here moved it 4 units that way. We'll talk more about that later, but what's the domain of this? Careful. It doesn't start at 0. Where does it start?
-4,
And where does it go to?
positive infinity.
Okay, what's the range? Careful. Range
0,
to,
positive infinity.
right. So the range didn't change, did it? The domain did, though. All right, now. The directions say find the domain of each function. Okay. So let me ask you this. Since we're taking an even root, can we take an even root of a positive number? Can we take an even root of a positive number?
I want to say yes.
Okay, then say yes. Can we
Say
take an even root of 0?
yes.
Can we take an even root of a negative number?
Yes.
Oh, you were doing
No.
so well.
I was
Okay,
like, no, I don't know.
all right. 2 big things. You can't take an even root of a negative number. And when you take an even root of a non-negative number, you can't get a negative answer. So if you've got an even root, the radicand inside can't be negative, and the answer outside can't be negative. So what I'm telling you is that this can't be negative, okay? So that means that this has to be positive or equal to 0. The radicand can't be negative when you're taking an even root. And the index, when there's no thing written, is an implied 2 for square roots. Okay. Are you getting this?
Yes.
So let's find the domain. Subtract 6 from both sides, x greater than or equal to -6. Writing it in interval notation, it would look like that. So there's your domain. If x is -6 or greater and you plug it in there, you're taking the square root of 0 or greater. You're not taking the square root of a negative number. So all I did was took the radicand and made it positive or 0, and then solved for x. Let's try another one. Find the domain. So what are you going to do? Take the radicand and make it greater than or equal to 0. Solve for x. So your domain, -12 inclusive up to infinity. This has to be non-negative. That is to say 0 or positive. So get another one. Find the domain. Since you're taking an even root, the domain, the radicand inside has to be greater than or equal to 0. Solve for x. Subtract 35 from both sides. Divide both sides by -5. Remember when you multiply or divide both sides of an inequality by a negative number, you change the direction of the inequality sign. So the domain now is -infinity up to and including 7. You okay with that? How are we doing? A lot of people always miss this on the test. Here we are. If you don't get it, speak up.
I'm a little confused. Can we do another one?
Absolutely. Okay. Let's see. T of A equals the square root of 3a plus 17. All right. Since the index is even, and you can't take an even root of a negative number, the radicand, the stuff inside, has to be either positive or equal to 0. Solving this for a, subtract 17 from both sides, divide by 3. So a is greater than or equal to -17 thirds. Even root, the radicand has to be positive or equal to 0. So you set it greater than or equal to 0, solve it for the variable, that gives you the domain. Anything in this interval that I plug in here, I'll get a real answer. Outside of this interval, so below -17 thirds, and I'm going to be taking an even root of a negative number, which is not real. We don't want to do that. Is it getting any better?
Yes.
How about the rest of you?
A little bit.
A little bit. Let's do another one. Let's see. F of x equals the square root of 4 minus 8x. Okay. I'm taking an even root. So the radicand, the stuff inside, can't be negative. That would make it positive if it was greater than 0. And that would make it 0 if it was equal to 0. It can be positive. It can be 0. It can't be negative. So you can do this, you can do that, but you can't do that. You can't take an even root of a negative number. That's why the radicand has to be greater than or equal to 0. Now, solving this inequality, I get that. Divide both sides by a negative number. I change the direction of the sign. Negative over negative is positive. 4/8 reduces to 1/2. So the domain is what? -infinity up to and including 1/2. Now, something that might confuse you is you might say, well, wait a minute, how can you put negative numbers in there? I thought you couldn't take the square root of a negative number. You can't, but look, it's 4 minus 8 times x. So -8 times a negative is going to be a positive number, right? So all of these numbers are going to yield a 0 or a positive number for the canned stuff inside. How we doing?
I got it.
All right, now, let's see here. This says find each function value if possible. It says do not use a calculator. All right, so f of x equals the square root of 3x plus 1. They want us to find f of 8 and f of -2. All right, so f of x equals the square root of the quantity 3x plus 1. F of 8 would be the square root of 3 times 8 plus 1, which is the square root of 24 plus 1, which is the square root of 25, which is 5. Okay with that? Any questions there? All right. F of -2 would be the square root of 3 times -2 plus 1, which is the square root of -6 plus 1, which is the square root of -5, which is not real. The book says undefined, and I don't agree with that because to me, undefined is dividing by 0. I would say it's not real, but in WebAssign, I think they'll give you some options as to what to write. And if it says, if it doesn't work to write that, do that. But I would say it's not real. Okay, what about this one? G of x equals the cube root of x minus 4. And we're supposed to find g of 12 and g of -23. Okay. So g of 12 would be the cube root of 12 minus 4, which is the cube root of 8, which is 2. G of -23 would be the cube root of -23 minus 4, which is the cube root of -27, which is -3. Now remember, you can take an odd root of a negative number. It's the even root you got to watch out for. Okay. Okay. Any questions about that? Let's do another.
I do have a question.
Yeah.
How you got on the second example? How you got
Okay.
number? Yeah, that one.
Yeah. No, the second one where it says 23, the cube root of -27.
Oh, right. This one? Antonio,
Yeah. Yes. How you got it?
how did I get this?
Yeah.
What's -23 minus 4 more?
Oh, okay.
Righty?
Okay.
So yeah,
Yeah.
I'm simplifying inside
Oh,
the
got
proven
it.
statement. All right.
Okay. Got it.
Good,
Yeah.
Good. All right.
I'm confused on how you got -3.
Okay. Cube root of -27 is what? What times itself is -27.
Oh, okay. Yeah, never mind. I understand now because it's 9, then 27. Okay.
Yeah.
Got it.
Okay.
Perfect.
Great. All right. Some more calculator problems. F of x equals the square root of x squared plus 1. Using a calculator, find f of 4 and f of 2.35. So f of 4 would be the square root of 4 squared plus 1, which is the square root of 16 plus 1, which is the square root of 17. And then going to the calculator, it says to round to the nearest 10,000th, which is what have you got? Tenths, hundredths, thousandths, 10,000ths. So we're going out 4 decimal places, and I get 4.123105626. 4 places would be right there. The 0 would round down. So 4.1231 would be my approximate answer. Okay. F of 2.35 would be the square root of 2.35 squared plus 1. Let's see here. 2.35 squared is 5.5225 plus 1 would be the square root of 6.5225. And then taking the square root of that, so second square root of 6.5225, I get 2.5539185558. Wrong color. But there's the fourth decimal place that's going to round down. So it's going to be what? 2.5539. Again, are you able to do that on your calculator or are you having difficulties? Okay. Now, simplify each cube root. We've already done the cube root of 8 is 2. The cube root of negative 27 is negative 3. How about the cube root of negative 125? Well, is there a way we can do that on our calculator? Yes, there is. We've talked about the square root button. There's something called the X root button, and it's right above that. So there's like a little caret key, and the second function above it, it's kind of hard to see. But if you look at it closely, there's a little X where the index goes. Can you find that button?
Yes.
Okay, so if I want to find the X root of something, let's say I want the cube root of 8, which is 2. What I do, I put in my index first. So with nothing on, my calculator's on, but nothing on the screen, I push a 3, then the second button. And when I do that, I get that. So now I have a 3 and then an X root. And then put in the number 8 and push equals, and you get 2.
Mhm. Got it.
I don't know if you can see that or not. Maybe not. Anyway, now notice that the square root put a parenthesis. This one doesn't. Let's take this cube root of negative 27. So what we're going to do is we're going to put in a 3, then push the second key, then the X root button. So now I've got that. I'm going to put a left-hand parenthesis. Then I'm going to put a negative, not the minus sign that's over on the right column, but the negative that's way down at the bottom. That looks like this. And then let's see, 8, and then close it up. And then you should get negative 2. So 3 second X root of parentheses, negative 8, close parentheses, negative 2. Try the cube root of negative 125 and see what you get.
I got -5.
Excellent. That's what you should get. Because you'd go that, and then you'd push the second key, which would then give you that, parentheses, negative 125, close parentheses, equals. Now, some of you might say, well, you know, you don't even need this other parentheses there, but I always caution you, because if you leave it out, sometimes it doesn't work, depending on what you're putting in there. So just be careful, be careful. All right. Let's see here, how are we doing for time? We're just about out. So, let's look at a couple more of these. How about the 6th root of 64? So I'm going to use my X root button. So I'm going to put in a 6 second X root of 64 equals, and I get 2. Try this. Put this into your calculator and see what happens. 6 second, negative 64. You should get this domain error. Remember, you can't take an even root of a negative number. That goes back to those problems where we found the domain. This can't be negative. All righty. Well, I hate to end on a negative note, but that's it for today. I'm going to stop the recording. So you've got section